live via the Internet. Welcome to ISP Radio, your weekly source for ISP-related news, events, and interviews with industry experts. If you deliver Internet via fiber optic, wireless, coax, or any other way, you're in the right place. Chat live with us weekly via ispradio.com every Wednesday at 11 a.m. Central Time. And now a brief word from our sponsors. Link Technologies, providing ISP consulting, support, and hardware for wireless ISPs. TowerCoverage.com, providing online RF coverage maps. Mimosa Networks, providing high-density, high-bandwidth radio products. Advanced LLC, providing retail and wholesale advanced communication services by matching providers with your bandwidth needs. And by Sitel, providing reliability in surge suppression. And now your host for ISP Radio, Steve Grabiel and Dennis Burgess.
Hello, welcome to another edition of ISP Radio. I'm your host, Steve Grabiel, broadcasting from Moriarty, New Mexico, and Dennis Burgess, our producer and co-host, broadcasting from St. Louis, Missouri. So, doesn't seem like there was a lot going on this week. We're all probably real busy with getting ready for Christmas and stuff. I have to say that my network has been performing like it's supposed to, knock on wood. Lightning season being gone, everything seems to work great when there's no lightning. Anyways, Dennis, you hear any news out there this last week of what's been going on maybe in the industry?
Well, we haven't had a whole lot of news in the industry. Remember, December 11th was the Form 477. It's the FCC form for wireless ISPs to go ahead and do all of the things that they need to do, report their broadband coverage area. That has passed and went, so we hope that everybody had a good time and didn't have any issues with getting that form put out and put in place. There was quite a few. We had some customers with over 38,000 census blocks inside their coverage area, and that's not one of the largest ones. That's not the largest one that we did, so we did quite a few of those as well. As far as upcoming shows, we actually have a number of things going on. Obviously, we have the holidays, both December 24th and December 31st shows. We're just going to say, hey, happy holidays, enjoy your holidays. There's no need to listen in. We will have, of course, our streaming server playing all of the latest episodes that we have. However, next year we have a show lineup already started up. January 14th, we're going to have Nathan Stuke from WISP ISP. He's going to be talking about over-the-top TV. We also have Net Sapiens on Wednesday, January 21st. Going to be talking about VoIP products there. I believe we are with their CEO. And then we're also going to have Patrick Leary with Telerad on January 28th. So we definitely have a show, a full show schedule starting up next year as well. Other than that, the only other hubbub that I have heard is I have heard some of the early adopters from Mimosa Networks. So if you signed up for their early adopter program, whatever that may be, has started to receive equipment. So this is a good sign, seeing that we are finally seeing radios and devices actually hit consumers. Other than that, we don't have a whole lot. Obviously, it's the holidays. People kind of slow down. Everybody, hopefully, is going to be getting their new budgets in the new year. I hope everybody does really great for the new year, and hopefully everybody's had a really great year as we have. So with that, back to you, Steve.
Well, I agree. Hopefully, all you guys out there that are listening and just the folks in general have had a great year, like Dennis said, and move forward next year with continued growth. One of the topics that I've heard a lot of and saw at the Wispalooza show, and I think Dennis even said it was his shirt that I saw people walking around. And the topic of today's show is bridging your network or routing your network. And there's nobody better with more knowledge about this than Dennis, so I threw out there the topic for our discussion today. And, why go from a bridged network to a routed network, or even vice versa, if it even makes sense? I don't think it does make sense, but no one's more up to date and knowledgeable about this than Dennis. So I thought I'd turn it over to Dennis to talk about the benefits, the pros and cons of doing one or the other. So Dennis, you want to start off and just tell us a little bit about the benefits, what it takes and how to do it. And I'll just throw in my 2 cents. You've helped me route my network through your book and through consultation. But my network's fully routed and seems to work pretty well. But Dennis, go ahead and start off the discussion.
Sure. So let me kind of give you a little bit of background, because I think and I feel that this is important that everybody understands where I come from. So originally, I started a wireless ISP in 2001, and way back then we did bridging. That's all we had. Very few routers, and we got into Microtech. That was there was Air Connect or Air Beams, I think it was. I can't remember the brand anymore off the top of my head. Very, very old equipment, and we went to CB3s, and it definitely went from there. However, since we've started Link Technologies, we have helped, I know well over 100, probably even into the hundreds of ISPs around both North America and the globe work on converting their networks from bridge to routed. Now, do we sit there and say that there's always a answer, that routing is always the answer? The answer is no, not always. There are definitely advantages, more along the lines of simplifications, to where you can allow your network to become simpler by doing selectively, or doing bridges selectively. We get a lot of wireless ISPs that use bridges in specific applications. So let's take a look at those applications. The very first thing is, of course, our access points. In many cases, the access points are bridges, and there's not a problem with that. Access point bridging is perfectly fine. The big thing you want to do here is do what we call customer isolation. Then we come back from that. So again, we're going to come from the CPE all the way out. From the CPE, we are going to route at our CPE, we can bridge our AP, and then when we go to the next step, what most people don't think of is our access points. So if we have 5 or 6 or 3, however many access points you have on your tower, should they be bridged or not? Should they be bridged together is the question. Typically, we would bridge those together, but we would place filter rules to prevent traffic between access points. So again, what we would do is we would have 3 or 4 or 6 access points on a tower. Maybe you have a cluster up there, maybe you have 4 90-degree sectors. Doesn't matter. You can even have more than that. You could have 4 90-degree 5 gig sectors, maybe you have 3 2.4 sectors, maybe you have 3 900s. Okay? Is it okay for you to bridge all of the access points that are bridged together? Yes, of course. And the reason for that is because you want to sit there and to share on that tower anyway a small IP space. So if you are giving out public IPs to your customers, it's definitely advantageous for you to sit there and say, hey, instead of me having, let's use the example, 3, 6, 9, say 9 sectors or 10 sectors, is it better for me to have one subnet that is larger versus 10 smaller subnets? For IP accounting, as well as trying to effectively use your IPs as effective as possible, it is definitely advisable to bridge those. But the big difference here is when we go back to what I would call customer isolation. And this has been done for years and years by many different companies. The goal is on your access points, you're going to turn off forwarding. Now, different access points call it differently. SM, isolation, forwarding, forward chain, take your pick. But basically, you prevent clients from directly communicating with each other. In other words, the client cannot ARP another client. When we go up to the next level, which is where we have all of our access points, yes, they may be all in one big bridge group, but what we simply do is we add the bridge group, and then we add a rule in the bridge filters to prevent forwarding between bridge ports. So the example would be, all my customers, if they send an ARP, the only place that ARP is going to get to, it's going to go through the CPE, it's going to go through the access point, and then it's going to terminate at the router itself, in our case, in a bridge group. But that ARP, even though it's a broadcast, will not travel anyplace else. It will not go to any other access points, and it will not go to any other client. Effectively, what we have done is we have created what we call port isolation. We can call it protected port status. We can call it customer isolation. But basically, every customer CPE can only talk to the router's IP address. They don't see any other IPs. They can't directly communicate with any of the other IPs in that same subnet. And that's a good thing. Our goal is to isolate our customers from one another so that if one customer does something bad, it minimizes impact. Now again, I always say route the CPE. I always route the CPE. I don't care if they are a residential or they are a business customer. In our case, if they're residential, we simply route the CPE and NAT at the CPE. So the CPE will have 192.168.88 or 192.168 something on the Ethernet port with a DHCP server, just like any other router. When we install a customer access point, we actually bridge that access point. So we may have like a 951U, which powers our radio. It has an access point and it has 5 Ethernets. All we simply do is plug in the PoE for the radio, and then we bridge everything together. Because in this case, it is isolated inside that customer network. If the customer does something such as creating a bridge loop or has a problem with the overall network in their home, it's going to hit that CPE, and the CPE in router mode will block any of those invalid packets, any of those flooded packets, any of those packet storms, just because by its nature it's going to be routing. For business customers, we typically route them a block. So if they pay for a business account, we would sit there and send them a /29, in which case the CPE still has a public on its WAN interface, but then we add another /29 to the LAN interface, and if the customer wishes to have DHCP, we turn that on. It's really up to the customer in that particular instance. So that is the access method. So when we talk about routed and bridged, we have to make sure we have some lines here. This is the access medium. This is how do we control the access medium, and then on top of that, how do we bridge and or route that? Steve, you have any questions on what I just said?
Yeah, I'm looking at my own microtics here, and you said something that's interesting to me. You've talked about shutting off, and I'm looking at a microtik right now. Out of the box, these things come with default forward checked. Are you suggesting that should be unchecked?
If you're looking at a wireless access point in a microtik, and that access point is designed for your final mile, okay, so that's an access point up on the tower, I would highly recommend you unchecking the default forward.
Okay. And then the other question is, as you mentioned, and I know that the folks you deal with a lot are doing the microtik client radio. Do you disable the default forward on that client radio as well, on that interface?
On the CPE, it doesn't matter because the CPE only has one registration.
Okay.
So the default forward option, or the forward option, is simply that it will allow two clients to communicate directly. And an example of that is, like at my home, I have my cell phone. I have a 2011 running an access point, and then I also have a Chromecast, which is only wireless. And one of the issues you have with that is you can't turn off default forward. And that's fine. It's not a big deal. Okay? But the goal of that is that if you leave default forward on, what happens is my cell phone connected to the same access point can directly communicate with my Chromecast, which is what it needs to do to be able to control the Chromecast. So that's an example of what that forward option does. But on a tower, whenever we're talking about customers, it should typically be very rare instances in which clients need to talk to each other. It even gets it's more rare on the same sector. It is less rare whenever we talk about the same tower. I have seen instances where maybe gamers or something like that, they're all off the same, 2 or 3 of them are off the same tower. Now, in our case, we can make rules. Okay, we can in microtik, both at the tower level as well as the access point, we can adjust that. We can allow exceptions to the rule. And we have done that in the past where, hey, we have 2 guys, they're gamers, they're both off this tower, but they're off different sectors, they're buddies. The only reason why the second guy got our service is because, guess what? He wanted to game, and his buddy told him. So in those particular cases, we make an exception. We know the MAC addresses of their CPEs, so it's very easy for us to allow, hey, if you're trying to come from this and to go from this, from here to go to here, we're going to make that exception because there's a legitimate need. But by default, we turn that stuff off until there is a legitimate reason to allow it. And then we don't turn it off. That's another thing, a mistake that many people make is they go, okay, let's turn a feature on because we know we want it. But then something's broke, something's not working, so let's just turn the whole thing off. That's not really the case. Really what you need to do is you need to troubleshoot. You need to figure out what the problem is. If it is a major impacting event, then yeah, maybe you need to turn it off. But in most cases, you can sit there, troubleshoot it for a minute, or at least a few minutes, and eventually come with a better solution than you had before.
Well, let me ask another question too. By turning off the default forward in this case, that's going to isolate, and this is true of a bridged or routed network, correct?
This is true of if the AP is fully routed. So in other words, if the Ethernet is routed and but the access point, think of an access point as a big hub, because that's really what it is. Okay, mm-hmm. And what happens is if you turn off that, if you leave the forward option on, that any clients connected to the AP, it's like a big hub. They can talk to each other. Mm-hmm. If you turn that off, the only thing they can talk to is either the actual wireless interface, which actually comes back into, there's more technical specs inside there. It actually comes through the mini PCI interface or through the PCI interface and actually talks to the board is one of the major reasons. But even if it's bridged with an Ethernet port, see, that's inside the software. That's inside inside the physical hardware. Whereas whenever you have that default forward turned on, that all happens at the radio card level.
Gotcha.
So
and my other question is so by disabling this default forward, and we're isolating the client, are we going to be able to isolate the client from them having malware on their machines or chatty Windows machines from gobbling up bandwidth?
Well, okay, so there's 2 things on that. So first off, if your CPEs are routed, okay, any type of malware or other application that typically is transmitted between Windows machines, so i.e. you have a local network and one machine gets malware and then all of a sudden the rest of them get it. Mm-hmm. A lot of those systems will transmit that through functions such as NetBIOS, etc. First off, you should have a router at the CPE to prevent that type of traffic from even exiting their network.
Right.
Okay. NetBIOS is there's no need for NetBIOS traffic on a ISP level network at all. Okay. You can completely discard that. So that's one thing. Will it prevent them from getting that? The answer is kind of yes and no, but the simple fact is that all you're doing is you're preventing customer A from talking directly to customer B in some way, shape, or fashion. Okay. And if you do that, if you go back to the tower router, okay, the tower controller, I usually call it a tower router because it is the one that all of our access points plug into and all of our backhauls. Whenever you filter on your bridge group there, that prevents access point to access point from talking to each other. Now, what is the downside of this? The only downside, and there's only one, is management access. Specifically, if you are off of a sector, you're at a client house, and another client calls and you want to log into their CPE, you cannot do it because we prevent traffic from one CPE going to another CPE.
Aha.
Okay. That doesn't mean that there's not a workaround. The proper workaround, which is very easy, is that you still have a VPN server. Most of your remote access should be through that VPN server, and simply put, you should VPN from the client site because technically the client site is not your office. It is not your management network. You see what I'm saying? So you should just simply VPN. Even though you're on your network, you should still VPN to your network. Now you have a management address that can get there.
Aha. So you're at a client's, just like you said, you're at a client's house and you get a call, and with default forward unchecked, you could not log in to see that. But if you were to log into a server on your network that has the ability to do that, you would be able to log into their equipment through that. Say, in my case, I have a 2008 server that I could get to and get to that client, correct?
Correct. I mean, that's the only downside. But like I said, a VPN is the easiest, quickest way to get around that.
Uh-huh.
You know, and look at it this way: you don't trust the internet at large. Why should you trust your customers any better for management access?
True.
You shouldn't. They're all just internet users. So for management access, you should limit that to completely your management subnets. And that's it. That would be my, for security reasons, that's my definite recommendation. Mm-hmm. Do you have to physically separate, or do you have to logically separate that with VLANs or something? No, you don't. I mean, I don't anyway. I'm not worried about someone sniffing the wire. I'm more worried about just someone trying to gain access from the outside.
Right.
So, I guess we should continue on. I mean, what we've talked about is our CPE and our access points, and then our tower router. Do you have any other questions? Or if you're online, make sure you hit ISP Radio and hit the little chat window. It's a little little bubble window. There's a home, there's the chat window, and then there's the archive window on ispradio.com. You can definitely hit that chat window, and if you have any questions, type it in there. We'll definitely try to get to them.
Well, one of my questions is, and I'm sure that this is going through the minds of some people that run a completely bridged network, how painful is it to go from a bridged network to a routed network? When I inherited the network I have, it was kind of half and half, and we went to a complete private network, and we read your book on setting up OSPF, and after we did it, it was pretty cookie cutter, but to ease the mind of people out there, how painful can this be?
Well, it's kind of a loaded question because it really depends on a number of factors. One, what hardware do you have in place? Mm-hmm. Two, the size of your network. Larger the network, of course, is going to take longer, but the process is the same. Three is public versus private IPs. It sounds dumb, but if you're giving private IPs to all your customers, which you shouldn't be, you should be trying to give publics, then we have basically a very large address pool to use, so IP limits are not there. But if you're giving publics out, we need to have enough publics to be able to do the conversion if necessary, okay? And then it really comes down to how widespread is the problem. So I'll give you a good, easy example, and I'll give you a really bad example, okay? Mm-hmm. So an easy example is that you have already been routing to the tower. You may have bridged backhauls. Even your access points and your backhauls at every tower may be all bridged together. But you have routers in place at the sites. Again, they may be bridging, but you do have a /27 or a /25 or however many IPs you need for that site on the router at the site. So any customer coming off of that site, that tower site, is already using a block of IPs that is dedicated to that site. Okay? Mm-hmm. So in that particular case, all we really have to do is build the OSPF system, build the back-end routing, and then simply change any IPs, such as your backhaul IPs in most cases, for management. Because the customers, we actually don't have an issue with. You see what I'm saying? The customers, we already have them in a IP block that is only at that tower site, so they're not spread out. Therefore, when we remove the backhauls from the bridging system, it's actually really easy. It's actually very simple for us to do that. And because it's simple for us to do that, the conversion process is very painless, very quick. On the flip side, we'll use a customer that has, let's say, 200 subs, completely bridged, switches, maybe tough switches, maybe regular switches, doesn't matter, at every site, and they have a /24 running at their NOC, and every customer was just random, basically assigned as they were installed. They just started going down the list. Oh, you're customer 35, so you get IP 35. You're customer 36, so you get IP 36, so on and so forth. In that particular case, we actually have a number of conversions to do. We have to deploy hardware in a mode that we can deploy and that we understand where things are going, so we have to label everything correctly. Once the hardware is deployed, then we have to build a routed system on top of the bridge system. So we actually run both simultaneously. So we have bridged and routing running simultaneously. The third step is converting your management devices, because all of your management devices were probably in 1/24. Now they have to be broken up. Anything at the towers needs to go on the tower subnets. Anything between the towers, such as bridges, etc., backhauls, will need to have their IPs changed per the new IP scheme. Okay, and it's just changing IPs. This is typically not something that Link Technologies anyway. What we do is we would do the bridged and routed. We overlay that, okay? But there's no point in us changing a whole bunch of IP addresses. Pretty much everybody here, anybody that's listening, I guarantee could probably change an IP address. So we let you guys do that, so you're not racking up hours and spending money unnecessarily.
Correct.
But once all that's done, so now we got those IPs changed. Now the hard part. The management devices are easy. The hard part is our customers. If we only had a single /24, we actually would not have enough IPs to roll new subnets out to the customers. Normally, if it's something like that small as a /24, we would just simply request another /24 with the intention of doing the conversion and handing back the original one. However, whenever you route, you do lose some IPs. And when I say lose, you do lose them in both network and broadcast addressing. But you also have to dedicate so many IPs per tower site. So if you have a tower site that has 9 customers, you need at least 14 IPs there. That's the smallest block you can put there. If you have a tower site that has 60 customers, or let's say 40 customers, you need to assign a block, or you typically would assign a block of 64 IPs. So what ends up happening is you end up losing portable IPs. The IPs that you normally, in a single /24, you can deploy anywhere. Now all of a sudden you've got 20 IPs that's only at this one tower, and you can't use it anywhere. So whenever you do route, you typically will need a little bit more IP space, and it all depends on where your customers lie, how big a blocks, etc. But we can plan that ahead. So let's say we get that new /24, we deploy that routing across that bridge network, just like we were mentioning. The hard part now is, how do your customers get the IP addresses? If they're all static, that means either you're going to have to log into the CPE, assuming it's the CPE, and change them. If it's DHCP, actually it's really easy, because we just simply do a rolling change. As they request new IPs, they'll get new IPs from the local DHCP server at the tower, and they'll be happy. If it's a customer that requires a static IP due to mail services, servers, etc., then that will have to be talked about, discussed with your customer, and a implementation time frame will have to be established for said customer. So in other words, customer, here's your new IPs, you got a new /29 block, it's already active, you can switch to them at any time, because we built that network on top of the other one. However, on XYZ date, the old IPs will stop working. So you have to mandate that. You're going to have to give them sufficient time to do that. You don't want to force it on your users, but if you don't, then what happens is on that cutoff date, you're going to get 30 calls from customers. Oh, my IP stopped working. Yeah, we've notified you 4 times about it, and you still didn't do it. So, you have to have that, maybe a little flexibility to turn them off once, turn it back on the next day, whenever you told them to, and then, give them another week and say, you have to get it done, because it's going to go off in a week. Once all that is done, once the IPs are all converted, again, if you're using DHCP or PPOE, it's actually pretty easy, very easy, okay? Then the last step is cleanup. And that cleanup is, now we need to start breaking the bridges. We have to change and make sure that the routing is working. By default, let me rephrase that. Per the method that we use, we will have a conversion process that we have a different OSPF type that works very well for bridged networks, but does not work well for anything else. Okay? Once we remove the bridge connections, we actually want to convert them to a much better network type that is faster and quicker, so that OSPF runs better. So overall, that is your process. Evaluation, here's your network, how many customers, what hardware do you need, etc. Deployment, which is the deployment of the actual physical hardware as needed. Next is dual stacking or whatever you want to call it, bridged and routing together, build the routed system, etc. Once that's done, now we have IP management changes, change management IPs, etc. We have customer changes, any necessary customer changes. The second to last step is bridge breaking. Let's break the bridges. And then the final step is that cleanup. Let's make sure everything's in the right mode. Let's make sure everything's running good. Once all that is done, now we can start getting into the real reason for having a routed network. In our case, we may have a link that is at capacity and we want to add a second link, so we can load balance across them. We may have rings that we want to close in so that we have more redundancy in the event of a tower going down or a link going down. Those are the big things with routing that helps us. And then going forward, as your network grows, whenever you get multiple connections in diverse locations, being able to get the customer out to the internet as quickly as possible by using the nearest gateway, as well as bringing that data back in, is again all routing. So those are the types of things that you'll need to do on the back end of that network.
Mm-hmm. Well, on the chat, Dennis, we got a couple of questions. I don't know if you noticed it. What do you guys think about having your routers at the core and dragging VLANs to your tower APs? So
the question, I'm just going to reread it. I think everybody heard you, but what do you think of having your routers at the core and bringing VLANs from your towers and APs? So I'm going to use a very specific example, and this is a real-world example of why this is not the best ideal. I'm not saying it can't work. Again, you can run a bridge network, and you can put tons of tons of effort into that if you want to, but I'm just going to use an example. Main backhaul coming in from about 6 other tower sites. That backhaul was a licensed, nice 300 meg. I think it was 360 meg. Is it 330 or 360? Doesn't matter. Nice licensed backhaul. They're only doing about 100 meg peak. Okay, that licensed backhaul is bringing 6 towers, 6 other towers. So we have about 7 VLANs, maybe 8 or 9 for some management stuff. All that's working fine. Everything's VLAN back. One customer at one site is a office. I'm trying to remember what kind. It was a real estate office. These people had a CPE coming down, plugged into a switch, and they had 5 or 6 computers. No big deal. Everything's been working. Okay. Well, the office expanded. They bought the place, not the building, but the next place in the strip mall. They run an Ethernet cable from switch 1 to switch 2 and put a couple more computers. Again, everything's working just fine. Well, the upstream provider actually had some type of problem, and internet was limited, as in speed was overall limited for whatever reason. And therefore, this real estate office decided, well, hey, we're having problems, so maybe it's the cable between the 2 switches. So they don't run a new cable, they run a second cable. Okay? This, of course, creates an instant bridge loop. And what happens in a bridge loop is specifically ARP packets or any type of broadcast packet really goes from one switch to the other, back and forth, and they start accumulating here. And what ends up happening is you end up getting 10,000 or 20,000 packets per second going out the CPE up to the AP across the backhauls. And this is where the problem lies, is that your switches, let's say they're HP Pro curves. Why? Because we sell them. Whatever. It doesn't matter what kind of switching system you have. Your switches, they're 20 million packets, 25 million packets, 100 million packets. That's not a problem for them. What is a problem is for that licensed backhaul. That licensed backhaul could handle about 22 to 25,000 packets per second. So what ends up happening is the packets are coming all the way back to the core, And it's not the performance that is the issue, it's the actual speed, the packets per second in this particular case. And because of that, of course, the issue being, even though you have customers and towers, quote, isolated, if you can see me now, I'm using those air quotes, isolated around that word, it's still going across the same medium. And because of that, what occurs is the backhaul radios basically die because they're hitting 100% CPU. And let's say they weren't licensed radios, if they were ubiquities or something, your packets per second is much lower. So what you end up getting is the CPUs are maxed on the backhaul radios because of one VLAN. And of course, that affects all the other VLANs that are traversing that link. It's not that any one or the other is better or worse, it's just simply a max packets per second that just happens to be occurring from there. Now, while I can sit there and say that, yes, that is an incorrect setup at the CPE, okay, and yes, if they had a router between those two, it could have prevented this issue. I'm just using this as an example, okay? I also do not feel that the current switching systems in bridge systems are adequate enough for failover of complex technologies. Specifically, I'll use this. Both RSTP, STP, etc., are not very good at handling a complex network topology failover. Are they fine at, hey, I have two links in path and I want to fail between them? Yes. Are they good at a ring topology, regardless of how big or small that is? Yes. Are they really good at some type of complex topology? No, I do not think so. Are there other switching systems out there that have been out there and have been trying to work in? Yes, maybe there is, maybe there isn't. I have not seen one that is cost effective out there. Okay? Again, is it possible? Yes, of course it's possible. I'm more along the lines of, I don't want to leave gaps in things that I've seen in the network that could occur, that could prevent issues, or that could cause issues. I like to prevent them. The other issue that we see a lot of times in those large VLAN systems is what happens when, let's say you're six towers deep. So just imagine the string of towers, A, B, C, D, E, F. If E goes offline, okay, completely, the customers at F have no gateway to reach. So there's no other direction they can go. Again, you can build in VRP and other technologies out there with a redundant gateway, things like that. But if that redundant gateway is back at the side A, you still have to have that. If there was a redundant internet connection, you could have used that. Again, there are pluses and minuses to both. I know some people like bridging, some people don't. Eventually, you will get to a size in which you have to route. I will also note this. If the internet at large routes everything, for the most part, why are not you? There is an example, something to be said. Whenever it works globally, we don't see the internet as a big bridge. So there's obviously other things inside there that we can take away from that.
Right. So it can be painful. It just depends on how you go about it. And your list is really good. I hope you guys wrote that down. If you are abridged and you're thinking about going to routed, Dennis gave us a great path to doing that, of how you go about implementing. And it sounds like the routed network rides right along with the bridge until a certain point where you do have to do the cutover. Yeah,
you definitely will. And something, one of the other people on the chat actually asked, that's how large telcos do it. Well, large telcos have large switching systems. Okay, they have that HP Pro curve, or whatever it may be, that can handle 38 million packets per second in switching. Okay, what we do not have as a wireless ISP anyway is radios that do that. You look at a lot of these wireless ISPs out there that they're using AirFiber 5s, they're using nano beams, they're using rockets, etc., that have very real world packet per limit caps that are nowhere near anywhere close to any type of a switching system. You know, I'm going to use an example, an inexpensive HP ProCurve 1810 that we use in many data centers. We use with some of our customers, as a matter of fact. Those are nice 52-port switches, and they're very low cost. Those things still run like 28 million packets per second. Whereas most of your wireless equipment, at least the 802.11 equipment that we're seeing, is going to be in the tens of thousands usually. So, you know, you do the math, you know, 24 million divided by, let's just say 100,000, you know, we're talking 2,400 times the switching capacity is inside that. And that's where our issue lies, is that if something does occur inside the switching system, what occurs is that the smallest device, you're only capable up to the smallest device that you have in line.
Right.
You know, it's just like bandwidth. If you have 100 meg links, but then right in between there you have a long one and that only does 20, then the entire link only does 20 meg. And it's the same thing. You're only as vulnerable or only as good as that weakest link. And unfortunately, that weakest link in wireless ISPs is the radios in many cases. Mm-hmm. And it's getting better. I mean, don't get me wrong. I mean, it's definitely getting better we have the EPMPs, we have, you know, lots of other systems out there, that is definitely getting better. You know, it's definitely better than it was, you know, but whenever we look at some of those things, you know, we're looking at 20,000 to 50,000 packets per second on some of the most common systems. Definitely, are there better ones? Yeah, there's better ones out there. But, of course, they cost more, too.
Mm-hmm. Dennis, we got another question on the chat. You want to address that?
Yeah, so first off, let me read it because, of course, it's always important. Not everybody's on the chat, and especially if they're playing it back later on. So the question is, do you think moving to an MPLS VPLS network would be an improvement over just an OSPF network for the throughput and IP utilization, addressed utilization, or would there be another way? And if there is a benefit, do you think it is worth the extra work out of a specific need for MPLS? So I'm going to give you my professional opinion. Okay,
that's what you're hired
is
for.
Not. Yeah, this is not going to be. This is not the maybe not everybody's opinion. And it may conflict with other people's, but it's an opinion. So the answer is, unless there is a very specific need to build layer 2 style tunnels, carrier tunnels, over your network in some way, in some business quantifiable manner. In other words, you have the local government wants to build 16 sites, and they're going to pay you $20,000 a month to do so. Okay, that would be a business reason to change your network. Okay? However, most of the companies that we work with, even the larger ones, do not really build a whole lot of layer 2 tunneling. They typically do not sell a lot of it, and even if they do sell some of it, it is typically built over other technologies such as OpenVPN, PPTP, and EOIP. The reason for that is that it's simply not a huge scale ability out there. Now, what does MPLS, or specifically VPLS, give you over that, over a standard routed network? Well, first off, MPLS VPLS runs on a routed network. So keep that in mind. You have to have OSPF running before you can even implement that in the best ways. MPLS, as far as performance, the ideal is the path, the packet path is figured out by your ingress point so that hopefully the CPUs on most of your devices are lower. In many cases, I do not see a significant performance savings or CPU savings in that, and typically the CPU savings, if that's getting you by, typically means you need more CPU anyway. So in other words, any CPU savings you would be getting from the MPLS system is probably just telling you that, hey, it's extending out something that should be fixed anyway. How is that? The big thing, VPLS, being able to easily build a layer 2 circuit, gives you a layer 2 circuit from point to point or point to multi-point without fragmentation. That's really the big thing. You're not taking a 1500 byte packet plus your Ethernet frame and fragmenting it. That does mean that you need to have configurations that may or may not be standard on many devices. You have to specify your MTUs, etc. And I typically find this to be, especially with networks of many different vendors, not necessarily problematic, but definitely something you have to work on. So I find that you end up building that and working on that quite a bit. Also, on top of that, you can use TE, or traffic engineering, with VPLS. So if you have a unused or a backup link, you could send layer 2 of this VPLS traffic over those links by doing traffic engineering. That is probably one of the big reasons for it. Again, is there a plus and minus? There's definitely pluses and minuses. If you currently are not selling layer 2 circuits point to point, then my recommendation is to not use MPLS and VPLS. There's no need to add the additional complexity. If it is a major goal, or if it is a business decision that requires you to build many of these tunnels, then MPLS and VPLS is a good option.
And like you said, it rides on top of an OSPF routed network, correct? It wouldn't replace that.
No, it does not replace it.
Yeah.
Now, I mean, there are extras in there. You can do BGP, VPLS. There's definitely some extra stuff inside there, but typically, and when I mean typically, for most ISPs that would be listening to the show, etc., is it a goal? Yes, it's definitely a good thing to do if you have the business need. But I always sit there and say this, is that technically, is there a reason for it? Not in many cases. And there's typically better ways of doing it that will make you more money and keep your network cleaner. So if I want to go down that road real quick, we do VPNs for companies. We do some medical facilities. And what we find, a proper routed VPN network will, one, keep your layer 2 traffic from traversing your network, so basically unnecessary traffic. It typically seems and ends up being quicker. In other words, the layer 3 VPN you can troubleshoot, and since it keeps those circuits cleaner, typically will run quicker. In other words, you have faster packets. Any fragmentation that needs to occur already is occurring inside the protocol. You add security. MPLS and VPLS does not add or encrypt data, okay, by default. So by default, you building a VPLS tunnel does not protect it in any which way, whereas a proper open VPN or IPsec tunnel would. And on top of all that, this is the big one, it works across what I call platforms, but across vendors. So the example being is that even if your network, you have a customer that has 10 sites and they want to add a site off net, now all of a sudden an MPLS network is very problematic because you have to go to another vendor, get that MPLS circuit terminated to your network, somewhere on your network, and then you have to carry it back for them. Whereas you just simply order an internet circuit for that customer, cable, DSL, whatever it may be, because they're outside of your coverage area, and you simply build it across existing layer 3 technologies, which, guess what, is the internet. I do know plenty of people like to provide carrier Ethernet or things for cell phone companies that would be more legacy type circuits. I just don't think that is a big market unless you have a big network. You know, I mean, it's one thing that if you have, 600 sites across 3 states, then yeah, that's definitely, there's much more business ability because you can sell it. But in many cases, we're providing internet out where there isn't those types of services. So, again, what we do is, instead of building tunnels and changing our ISP network, what we do is we sell a managed router that provides the VPN.
Right.
Okay.
So, managed router is the best way to most cost effective unless there's a business case for going to MPLS. It's easier to just build a VPN.
Right. I mean, and there's no changes to your network in that particular instance. You're providing and it makes, think of it this way, it also makes business a little bit easier to me. I'm selling them a 10 meg by 10 meg connection. Oh, you want a VPN? Well, you still have a 10 meg by 10 meg connection. That doesn't change. I'm not giving you extra bandwidth for your VPN. You see what I'm saying? So
right.
it makes the ISP side very cut and dry. And then you go, okay, for XYZ for $80 a month, I'm going to drop in a managed router. That will be your firewall. We will manage that firewall. If you need network address translation or anything opened up, you give us a call. And that managed router, we will build a VPN from site 2 to your core site. Oh, and you need a managed router there because, we have to have someplace to terminate the VPN. So now we're at $160 a month. And whenever they go, oh, well, the VPN seems slow. Well, you got 10 meg. You need more.
Yeah.
Because that's your internet package. It's not a separate thing. It's the same thing that would happen. Again, go back to the remote office that's off-site. It's the same thing that would happen there. You have a 20 meg down cable modem with 1 meg up. Your uploads are going to be slow. It is what it is.
So I got a question for you. You mentioned about going to a routed network and getting public numbers and stuff. Well, we all know IP4 is going away, running out of numbers. And I know this could probably be a case for another show. What about IPv6?
Sure.
Say someone wants to go from bridge to routing and realize there's no IPv4 out there. How hard, and like I said, maybe this is a topic for another show, of obtaining IPv6 space and converting your network to that type of network?
Good. That's a really good question. So first off, let's kind of go over the V4. We are not going to convert from V4 or off of V4, in my opinion, for the next 20 years. Okay. Will we start seeing that conversion? Will we start seeing that people will not be doing a whole lot of that, a lot of those conversions? Yes, we'll start seeing that. But in the end, you're still going to use V4 in some way for a good while. Okay. Right now, there's 93/22s available from Aaron. So there are IP space, or there is IPv4 space out there. As far as getting IPv6, the requirements are very easy. The cost is very low. You get a big block. For most ISPs, you're going to get a /32. That's a lot of IPs to start with. As far as running that, OSPF, let me rephrase it, V4 and V6 are not compatible. They are not the same thing. There are translation services between them, but typically what we're going to see is you're going to see dual stack setups. In that particular case, you have two routing protocols. You have OSPF, and you have OSPF v3, which is the IPv6 version of OSPF. And they are completely, for all practical purposes, completely separate. So, can you do that? Yeah. It's just a matter of installing V6, setting up OSPF v3, and then setting up for deployment in said space. And you do get there are some interesting things in the client side, but everything as far as bridged and routed goes still applies. Mm-hmm. Okay? The only difference that we would do is in V6 addressing, we would assign a /64 to our bridge group at the tower. That's all of our sectors. Our CPE would get a auto-config IP, and then we would assign something like a 56 or a 57 of IP of 64s. So we would assign 128 or 256 /64 addresses per tower to be assigned. And that's what we call IPv6 PDing, or prefix delegation. So then our CPE gets a /64 from the pool of 64s and applies that to the Ethernet interface. And then any device behind that would immediately get that. If we needed to provide a local link addressing or /112 addressing between the client site and their router, of course we can do so. That's not a problem as well.
So if a ISP was going to go to IPv6 do the CPEs that you see out there, I know a Microtech CPE would be able to do it, but I mean, the other ones, are they compatible, or would that be a forklift upgrade?
Yeah, I mean, it is a concern. I mean, there are CPEs out there that do not have V6 stacks at all. Now, I want to make sure I point this out, is that just because a backhaul radio does not have V6 management ability does not mean that you can't use V6, and that doesn't mean it won't pass V6. Okay? In many cases it will. It's just that does it understand V6, and can it do all of its management functions with V6? That's really the question. As far as the CPE goes, we use Microtech for pretty much everything, and I do not have an answer on Ubiquity. I'm assuming their air routers and some of their newer CPEs would have V6 stacks that can do prefix delegation requests and attachments. I do not have any experience in doing that, because most of the networks that we run V6 on, we typically do PPOE, and the PPOE client gets it, and it's usually a customer router.
Right.
But I do know, to be honest with you, I'm pretty much sure, I can tell you many of your CPEs are going to do V6, but anything older may not.
Do you believe that would be a chipset upgrade, or is that a firmware upgrade?
In most cases, it should just be a software upgrade, because V6 has been out for a long time. But again, it could be also something that the manufacturer of the radio may never have plans to upgrade that.
Right.
You know what I mean?
Dennis, we've got one more question on the chat, and then I think we could wrap it up. You've given us wonderful advice today.
Sure. Let's see here. As to the IP space, what should a ISP with about 400 customers be asking for from Aaron for Publix? Well, I mean, if you have 400 customers, so you need at least 400 IPs. They're going to come in 256 blocks, so you're going to need, typically you're going to see a /22, but they are allocating down to /24s. The answer is you would do proper due diligence. If you came to Link Technologies and you said, hey, I have 400 customers, I need to know how many IPs I need to get from Aaron, what we would do is we would ask specifically for how many tower sites do you have, how many customers do you have on each tower site at this point in time, and then are there any tower sites that you are going to be growing rapidly? In other words, plus, say, 20% in the next 3 to 6 months. And we would come up with a IP routing scheme. In other words, how many IPs to assign to each tower. And that will pretty much tell us exactly how many /24s or more that you would need to request from Aaron. Because what you're going to have to do is you're going to have to show that you can use the IP space that you got. If you're just a single home provider, then you will need to show usage. You will also need to show that your ISP is not giving you any IPs. In some cases, you can get a letter from them. As far as the whole process goes, what we would normally do is just have you call in, create a ticket. It is consulting time for us, so it would be we can handhold you as much as you want, or we can just help you with the whole process. We've even went as far as, hey, let's go ahead and hit up, we'll actually create an Aaron account. We actually, for you, and help you with that, help you get your Aaron account set up and registered, etc. So, there are plenty of things you can do, but, again, that's the process I would go through. You have to do your due diligence. It's not just hey, I have 400 customers, so I need 512 IPs, because you will be using some of them and keeping some reserved for other towers. So you may need more than that, but without looking at your exact numbers, it's impossible to tell. More information is needed to give you a hard answer, if that makes sense.
And isn't multi-homing a big consideration with Aaron and allocating any IPv4?
Not as much in Phase 4 anymore. So in Phase 4, which is what they are currently in, they are giving blocks smaller than /21s and multi-homing. Even though multi-homing is a fairly big requirement, there can be other circumstances now.
Well, like you said, with your upstream provider telling you we're not giving you any more IP.
Yeah, I mean, it does happen, but you will need to make sure that your upstream gives you that documentation. Because Aaron is all about documentation. Mm-hmm. And we've worked with Aaron with many customers. You know, if I go on my particular Aaron account, I bet you I couldn't even tell you how many customers are listed in there. We work with them a lot. And it's really just about going through the due diligence that Aaron wants and requires. And it's all documented. It's all there. Aaron is not Aaron is not the proverbial 500-pound gorilla. They do have their policies and procedures. And it's the same thing when customers ask me, you know, we have our policies and procedures. We would never go to you and say, hey, we want you to change your policy just for us. So we can't go to Aaron and say, hey, you know, we're special. We need to get changed, you know, have something changed. So it's all about those policies. They're all documented. They're all well thought out. And it's really not difficult if you have the proper documentation and can give them that. And that's really what you have to have.
Well, good. Well, Dennis, I think that's it for today. If you got anything else, a great show. I appreciate you giving us, you know, the positives and negatives of routing versus bridging. And, you know, just like your shirt says that you had at WISPalooza.
Yeah, friends don't let friends bridge networks. We have done that for, years. We've had those shirts and such. So,
yeah. Well, if you want to wrap up the show, we will talk to you all next week. Next week we are off, and we will be back after the new year with some new guests to talk about the products that they offer.
Yeah, and I'm sure, I'm just looking at our schedule, we should be back on air on Jan 7. We don't have anybody slated, but I don't see any reason why we wouldn't be back on air. But if you do have any questions, of course, send those questions to sales@ispradio.com. Take it easy, guys.
Thanks.
ISP Radio. We hope you've gained new insights and additional wisdom in our industry as well as your business. Please remember to visit our show sponsors via the links on ispradio.com. If you're interested in becoming a show sponsor, contact us at sales@ispradio.com. Now go out there and push those packets as fast as you can. Good luck and Godspeed.